Good morning, everyone. I am Vireshwari, Assistant Professor from EEE Department, Shriram Engineering College, Tirupur. Today, I am going to present the topic Power Scenario in India. In this presentation, we will understand the development of the Indian power sector, present installed capacity, renewable energy growth, power demand, government policies, distribution reforms, challenges, and the future vision up to 2030. The data in this presentation is referred to the Ministry of Power, Government of India as of 31st January 2026. In this presentation, we will cover evaluation of India's power sector, installed capacity, fuel-wise generation mix, renewable energy growth, generation to consumer value chain, raising electricity demand, government policies, rural electrification, distribution sector reforms, regional grid structure. Then, what are the challenges we faced? Vision of for 2030. Simply, we are saying starts from the historical development of the power sector and finally discusses where India is heading by 2030. Next slide. Evaluation of India's power sector. This slide shows how India's electricity sector has developed over time. 1947, at the independence, India's installed generation capacity was only about 1.4 gigawatt. After that, 1990s to 2000, India entered a major reform area. The Electricity Act 2003 was an important milestone. It also led to restructuring and unbundling of state electricity boards. At the time of 2015 and 16, the installed capacity reached approximately 270 gigawatt and renewable energy development started growing rapidly. Now, 2026, installed capacity reached 520.5 gigawatt. India's installed generation capacity has increased nearly 380 times since independence. It also states that 52,536 megawatt was added during financial year 2025 to 26 up to January 2026, with 82% of this addition coming from renewable sources. From this, we can understand India's how transformed in this power sector industry from just 1.4 gigawatt in 1947 to more than 520 gigawatt in 2026. Next, installed capacity at a glance. As of 31st January 2026, India's total installed capacity was 5,20,511 megawatt. Out of this, non-fossil capacity 271,969 megawatt. Fossil fuel capacity 2,48,542 megawatt. Therefore, non-fossil fuels gives 52.3% and fossil fuels 47.7%. An additional 52,536 megawatt of capacity was added during the financial year 2025 to 26 up to January. The ownership pattern was approximately private sector 53.8%, state sector 22.8%, and central sector 22.2%. What is the important thing from this slide? Means non-fossil sources have now crossed 50% of India's installed capacity. India's power sector is no longer dominated only by conventional sources. More than half of the installed capacity now comes from non-fossil sources. Next, fuel-wise installed capacity mix. Here, this slide compares different energy sources. The capacity share is from the source coal 42.5%, solar 27%, hydro 10.8%, wind 10.5%, gas, lignite and diesel 5.3%, biopower and waste 2.3 percentage, nuclear energy 1.7 percentage. Coal remains the largest individual source with 42.5 percentage of installed capacity. Solar has grown rapidly and accounts for 27 percentage. Wind and hydro energy power together they contribute more than one-fifth of installed capacity. Nuclear capacity has increased significantly and is reported at 8,780 megawatt. Although renewable energy is growing rapidly, coal still plays an important role in maintaining grid reliability. Next, renewable energy, the growth engine. The installed capacities are shown in figure: solar, wind, hydro, biopower and waste, nuclear. Non-fossil capacity has reached 52.3% of India's total installed capacity. India is also moving toward the 500 gigawatt non-fossil capacity target for 2030. Now, solar energy is currently the largest contributor among the renewable sources. The rapid expansion of solar and wind is changing the structure of India's electricity sector. Next, generation to consumer value chain. This slide explains how electricity reaches the consumer. We have four major states, that is generation, transmission, distribution and consumption. First one, generation. Electricity is produced in thermal power plants, hydroelectric plants, nuclear plants, solar plants and wind farms. From that generated power transmitted, we, generated power will be transmitted. Electricity is transmitted at high voltage over long distances. High voltage transmission reduces losses during long distance power transfer. Next, distribution. Distribution companies called discoms receive electricity and distribute it to consumers. The voltage is stepped down to suitable levels, then it will be distributed. Consumption. Electricity finally reaches houses, industries, agriculture, commercial establishments, services. India operates a very large synchronizing grid under the concept of one nation, one grid, one frequency. For example, just like water, the water travels from a treatment plant through pipelines to our homes. Electrical power travels from generating stations through transmissions and distribution networks to consumers. Next, rising power demand. India's electricity demand is increasing rapidly. India's electricity demand is increasing rapidly. The PPT shows the peak demand increased from 156.9 gigawatt in financial year 2015 to 16 to 270.8 gigawatt in May 2026. This represents approximately 73% growth over the period. What is the reasons for increasing in demand? Why is demand increasing? Then the reasons are increasing summer temperature, air conditioning and cooling loads, industrial development, then urbanization, increasing household electricity consumption, economic growth. The renewable energy, including hydro, contributed 34% of power at the peak demand hour. India develops economically, electricity demand also increases. Therefore, India needs not only more generation capacity but also stronger transmission and distribution infrastructure. Next slide. Key government initiatives. This slide discusses major government programs, that is Saubhagya, Uday, RDSS, PM Kusum, PM Suryagar, National Green Hydrogen Mission. First one, Saubhagya. The objective was to provide electricity connections to households, particularly previously unelectrified households. Second one, Ujjwal Discom Assurance Yojana, that is Uday. Ujjwal Discom Assurance Yojana. It was introduced to improve the financial condition of electricity distribution companies. Then RDSS. RDSS means Revamped Distribution Sector Scheme. Its objective is to modernize distribution infrastructure and reduce losses. Uh, then PM Kusum promotes solar power for agricultural irrigation and helps reduce dependence on diesel. Then next one, PM Suryagar. It promotes rooftop solar for households through financial support. Then last one, National Green Hydrogen Mission. Uh, it promotes development of green hydrogen with an outlay 19,744 crore. These schemes show that the government is working not only on in generation but also on distribution, renewable energy, agriculture, and emerging technologies. Next, rural electrification and access. Powering every home. That is the main goal. Powering every home. 100% village electrification on April 2018. 2.6 plus crore households connected under Saubhagya. Our main goal is 24/7 power supply. That is, every time we have a power supply. The focus has moved from simply providing electricity connections to improving quality and reliability of supply. Remote areas can also be supported through solar microgrids, off-grid renewable systems. That is, electrification does not simply mean connecting a house to the electrical network. The ultimate objective is reliable and continuous electricity supply. Next, distribution sector reforms. Distribution is often considered the weakest part of the electricity value chain. The main thing is here we are having some losses. What are the losses? That is ATN losses. ATN, ATNC losses means aggregate technical and commercial losses. First one is here the aggregate technical and commercial losses include technical losses in electrical networks, electricity theft, metering problems, billing problems, collection inefficiencies. That is, losses have reduced considerably but remain higher than the global benchmark of approximately 6 to 8%. We are having also ACS ARR gap, that is 0.78 per unit. It will be reduced to 0.06 rupees per unit. From the financial year 14 to financial year 25, it also gives an RDSS target of 12 to 15% of aggregate technical and commercial losses. If electricity is generated and transmitted efficiently, but the distribution company loses a significant amount through technical and commercial losses, the overall power sector will still face financial problems. Next, India's regional power grid. We are having five major regional grids, that is northern region, western region, southern region, eastern region, northeastern region. Here we are seeing about the individual region states. All these regional grids are synchronized at 50 Hz. This allows electricity to flow between regions depending on generation and demand. This is the practical meaning of one nation, one grid, and one frequency. Next, challenges facing the power sector. Power sector facing five major challenges that is shown in this presentation. That is, first one is discom finances. Distribution companies continue to face financial difficulties because of revenue gaps. Second one, high AT&C losses. National AT&C losses are shown as 15.04%, which is still above the 6 to 8% of global benchmark. The next one is coal dependency. Coal accounts for 42.5% of installed capacity, creating environmental concerns. Fourth one, grid bottlenecks. Transmission constraints affecting renewable energy evacuation. Grid balancing. Solar and wind are variable sources. For example, solar generation decreases at night. Wind generation varies with wind conditions. Therefore, the grid needs energy storage, flexible generation, better forecasting, strong transmission networks. There are also land acquisition and right-of-way issues affecting projects. The next slide, Vision 2030, road ahead. That is 500 gigawatt non-fossil capacity. India has target of 500 gigawatt non-fossil capacity by 2030. Green hydrogen. India plans to scale up green hydrogen production. Third one is energy storage. 43 gigawatt hour of battery storage under development through viability gap funding support. Fourth one, offshore wind. Offshore wind projects are planned along India's coastline. Fifth one, smart grids. Digital technologies can improve metering, monitoring, automation, demand management, loss reduction. That is, developments with reducing AT&C losses toward 12 to 15% and supporting India's long-term net zero by 2070 commitment. Finally, the conclusion is India's power sector is undergoing a major transformation. The focus is shifting from simply increasing generation capacity to achieving a cleaner, smarter, more reliable, and financially sustainable power system. Thank you.